Hello, this is Mrs. Dehn-Brastad, and today we are going to continue our Chapter 2 with Section 2 on Conditional Statements. This section is kind of fun. You get to rewrite sentences in some different ways and just kind of break them apart and look at the different parts of a statement. It's almost an English lesson, but it's math, it's geometry. So the things you learned in Chapter 1, you still need to know. So you should know all of these. This is just a quick warm-up. Go through these and then pause the video and then come back and check your answers. Okay, number 1, the measure of an obtuse angle is less than 90 is false. It's greater than 90. Number 2, all perfect square numbers are positive. That is true. You can square any number, positive, negative, fraction, it doesn't matter, and you'll get a positive answer. Number 3, every prime number is odd. That's false. We did this in the last lesson. The prime numbers, the first prime number is 2. That is the only even prime number, but there is an even prime number, so therefore that's false. And number 3, any 3 points are coplanar. That's true. You only need 3 points to have a plane, so any 3 points will be coplanar. Our objectives today are to identify, write, and analyze conditional statements and the truth value of conditional statements, and also to write the inverse, converse, and contrapositive of a conditional statement, and we'll learn what that means in this lesson. So our vocabulary, a little bit more than last time: conditional statement, hypothesis and conclusion, the truth value, negation, converse, inverse, contrapositive, and then logically equivalent statements. All right, here's our first two. A conditional statement, verse 3. A conditional statement is a statement that can be written as an if-then statement, like if P, then Q. If something, then something else. The part that comes after the word if, the P in this little example, is called the hypothesis. The part that comes after the then is called the conclusion. So here's an example. And I'm going to underline these. I'm going to underline the hypothesis with a dashed line, and then I'll underline the conclusion with a solid line. Sometimes they use 1 line and 2 lines for each. So the hypothesis is you buy this cell phone. So that's the hypothesis. The conclusion, if you buy the cell phone, then you will receive 10 free ringtone downloads. So this is the hypothesis. This is the conclusion. Now, it's nice if they give it to you in if-then form, but sometimes they don't. Sometimes you have to rewrite it. If you had a sentence like this next one, a person who practices putting will improve her golf game. In that one, we have to write it a little bit differently so that it's an if-then. So what we wrote is if, we just added the word if here, if a person practices putting, then she or he will improve her golf game. Okay? So you might have to add words or take away words in order to turn it into an if-then statement, and that's okay to add or take away a couple words. So if a person practices putting, then she will improve her golf game. We had to add, the if and the then, but also we have to rephrase the person or the she or the pronouns and things. Once you've written it as an if-then, then look, oh, here's the hypothesis. A person practices putting, and the conclusion is she will improve her golf game. Okay, now we are going to look at these ones. We are going to, if we need to, rewrite it so that it's if something, then something, if we have to. And then we're going to pick out what is the hypothesis, what is the conclusion. If today is Thanksgiving Day, then today is Thursday. So it's already in if-then form. So the part after the if is the hypothesis. The part after the then is the conclusion. So when you do your worksheets, you can either underline them in 2 different ways, like a dashed and a solid, or a single underline and a double underline, or you can just type out what is the hypothesis, what is the conclusion. Okay, the next one says a number is a rational number if it's an integer. The if is in the middle here. The part after the this after the if is going to be the hypothesis. I'm going to rewrite this right away. If it is an integer, that sounds funny, doesn't it? I'm going to say if a number is an integer. So I'm adding a word in there to make this make sense. If a number is an integer, then, now I'm going to go back to the beginning part. Now I don't have to write a number is a number, a rational number, so I can say then it, I already used the word number, is rational or a rational number. So we're rewriting it in if-then form, and then we can tell that the hypothesis, that's the part after the if, I'm going to get a different color. I'm going to do the hypothesis in green dashed line here so you can see it. And the conclusion is it is a rational number. So we've got our hypothesis, we've got our conclusion, and that's what we needed. Here's another one. Try this. Pause the video and see if you get it right. The if's in the middle, so it's a little bit trickier. I'm going to rewrite it so that it's an if-then form. If it, what's it? It's a number. If a number is divisible by 3, no, by 6, then, and now I need the rest, then it is divisible by 3. Once you rewrite it in if-then form, then it becomes much simpler to find the hypothesis and the conclusion. The hypothesis is just the part after the if, there it is, and the conclusion is the part after the then. So the hypothesis is a number divisible by 6, conclusion, a number is divisible by 3. There's other ways to write if P then Q. You might see if P comma Q. You might see Q comma if P. That's kind of what we just did. The if was in the middle. P implies Q. P only if Q, and P with an arrow pointing to Q. Those are all different ways you might see it. Many sentences without the words if and then can be written as conditional. And in order to do that, it's probably easier to figure out what is the hypothesis and what is the conclusion first. It's kind of like domain and range or independent and dependent variables. What depends on the other one? Which one are you given to start with? That's your hypothesis. And then the conclusion is what would be based on that. Let's see if we can figure it out with this one. And an obtuse triangle has exactly one obtuse angle. So what part are we starting with here? Are we starting with that we're holding on to, or that we're looking at an obtuse triangle and then we're trying to figure something out about it? Or are we starting out with the angle and we're trying to figure something out about the triangle? It seems to me that we're starting with an obtuse triangle, which means it has one angle that's obtuse. And then from there, we can make, a conjecture. We can say, well, then I think it only has one obtuse angle. So the hypothesis of that statement then would be an obtuse triangle that we're holding on to, that we're looking at an obtuse triangle. And then whoa, how did I do that? I was going to erase my line and make it a dashed line like I had before. So this would be the hypothesis, and then this would be the conclusion. So when I want to write it as an if-then, I would need to say if you have an obtuse triangle, or if a figure is an obtuse triangle, or if a triangle is obtuse, then it has exactly one obtuse angle. So they wrote, if a triangle is obtuse, then it has exactly one obtuse angle. So you've got your hypothesis and your conclusion. Sometimes you will see these with Venn diagrams. In this one, the blue jays are a subset of the birds, and the whole box might be, I don't know, animals. So this means that, does it mean that if you are a blue jay, then you are a bird? Or does it mean if you are a bird, then you are a blue jay? It says that the inner oval represents the hypothesis. and the outer oval represents the conclusion. So you would say, if it is a blue jay, then it is a bird, which makes sense. If an animal is a blue jay, then it is a bird. All right, let's see. Try this one. Two angles that are complementary are acute. Where does the if and the then go? What are we starting with? Are we starting with that we have two complementary angles, or are we starting with then they're going to be acute? It looks like we're starting with two angles that are complementary. And then the conclusion is going to be that they are acute. So this is your hypothesis, and then this will be your conclusion. So with an if-then, you're going to say something like, if two angles are complementary, then they are acute. All right, conditional statements, which are the if-thens, they have truth value. They can either be true or false. We haven't bothered saying whether they're true or false up to now. It's only false if the hypothesis is true and the conclusion is false. So the only thing that you have to do to show that it's false is you need to find one counterexample where the hypothesis is true and the conclusion is false. All right, so let's look a little bit closer at what this means. Here's an example. Analyzing the truth of conditional statements. There's 4 cases that you could have. Remember, it's if, hypothesis, then conclusion. A conditional statement is true if the hypothesis is true and the conclusion is true. Well, that makes sense. If they're both true, it's true. A conditional statement is true if the hypothesis is false and the conclusion is false. That might seem odd, but we're going to look at an example that will help you clear that up. A conditional statement is also true if the hypothesis is false and the conclusion is true. A conditional statement is false only if the hypothesis H is true and the conclusion, that's supposed to be a C, is false. That's the only time you could say this is false. Here's an example. If it is raining, that's my hypothesis, I will bring an umbrella. That's my conclusion. All right, example or possibility 1 is that a conditional statement is true if the hypothesis is true and the conclusion is true. So that means that a true hypothesis means it is raining, and a true conclusion would mean I do bring my umbrella. So if it is raining, I will bring my umbrella, and it was raining, yep, and I did bring my umbrella, yep, then we would have a true statement. Okay. Second instance that we could have. If the hypothesis is false, it's not raining. Nope, not raining. So whether I bring my umbrella or not, it's still a true statement because I can't really judge. If it's not raining, I can't finish the sentence. I can't say I will bring an umbrella because it's not raining, so it doesn't make any sense. It doesn't matter if I bring my umbrella or not, it's still a true statement. You can't call me a liar if we do not have the right circumstances to judge what I would do if it did rain. So as long as it's not raining, you will assume that I will bring an umbrella if it was raining. It's not, so you can't tell me that I'm not going to. But in the case of number 4, possibility 4, if the hypothesis is true, it is raining, and I don't bring my umbrella, now you can say that my conditional statement is indeed false. Okay, so if the hypothesis is not true, you can't judge anything about what you would do because you're not in the right situation, so it's going to be a true sentence. We will keep assuming that it'll be true. All right, let's look at this one. If this month is August, then the next month is September. So first of all, is the hypothesis true? When I'm making this video right now, it's September. It's not August. So I would have to say that this is a true sentence because the hypothesis is not true, which means I don't know what's going to happen in the future. However, I do have a calendar, so I'm going to flip back a month and pretend that, yep, it's August. Okay, so now I've got a true hypothesis. Then would the next month be September? Yes, because the calendar says it's so, and you memorized it back in 1st grade. So then this is true, either way, whether or not you have you assume that the hypothesis is true, or if you assume the hypothesis is false, because the conclusion is going to be true. When the hypothesis is true, the conclusion is also true. So the conditional is true. Okay, if two angles are acute, then they are congruent. If two angles are acute. So if the hypothesis is true, I have to have two acute angles. Let's say I have a 30-degree angle and I have a 35-degree angle. Those are two acute angles. The hypothesis is true. The conclusion has to be that they are congruent. I just did not draw two congruent angles. I made 130 and 135. Those are not congruent. Therefore, this is a counterexample that shows that this statement is false. I only have to have one counterexample. I have two acute angles, and they're not congruent. So therefore, the hypothesis is true, but the conclusion is false. So that is your counterexample. If you can find a counterexample, then your conditional is false. Okay, one more. If an even number greater than 2 is prime, then 5 plus 4 equals 8. Don't even worry about the conclusion. Look at the hypothesis. An even number greater than 2. Here's our, one more time, our prime numbers. 2, 3, 5, 7, 11, 13, and so on. The only even prime number is 2. There is no even numbers greater than 2 that are prime. This hypothesis is always false. If you have a false hypothesis, then you can't judge whether or not your conclusion is true. Now this seems bizarre, but this is a true sentence. This is a true conditional statement because the hypothesis is false, so I'm never going to be able to judge whether or not 5 plus 4 equals 8 because I can only do it when you have an even number greater than 2 that's prime. And there is no even numbers greater than 2 that are prime, so we never get to go into this world where 5 plus 4 equals 8. It's true because the hypothesis is false. All right, if a number is odd, then it's divisible by 3. If false, give a counterexample. So do that one, pause the video, then check your answer. Here's an example of an odd number, 7. 7 is not divisible by 3. You'd get a decimal. So the hypothesis is true, you have an odd number, but the conclusion is false. So since you found a counterexample, the conditional is false. Remember, if the hypothesis is false, the conditional statement is true regardless of how much sense the conclusion makes. It can be the most bizarre thing in the world. You can say, if -1 is positive, then pigs fly. This is a true statement because the hypothesis is false. -1 is not positive. So then the conclusion, it doesn't matter how goofy the conclusion is. This is a true sentence, a true conditional, because the hypothesis is false. It's like if -1 is positive on some world, then I guess pigs fly. So it's true. Negation, this is an easy little thing. Negation is what you probably think it is. It's when something is not. You add the word not in there. You change it to the opposite. So we add or take away the word not to a sentence, and that negates it. That changes it to the opposite. You can use the curve, this little, on your keyboard, it's right to the left of the number 1. There's this little, it looks like a congruent sign, but only the part above the equal sign. It looks like the similar thing too, but it just means not P. You may also see it as like not P, like a kind of a bracket. So that means it's negated. This is just the way you can write conditional statements. If P, then Q. We can write something called a converse. You write a converse by taking, I'm going to put the conditional back up. The conditional is if the hypothesis, then the conclusion. When you are going to write the converse of something, you flip-flop the converse and the hypothesis. So if the conditional, then the hypothesis. So you exchange the hypothesis and the conclusion. The inverse is when you leave the conclusion and the hypothesis where they were. So if hypothesis, then conclusion. But you put the word not, or you take away the word not from both of them. So if not H, then I'll just use the word not C. Whoa, where'd it go? So if not the hypothesis, that stays in the same place, then not the conclusion. Hey, I know what happened. I went, there it is. I wrote that other one in the wrong spot. If not P or not H, the hypothesis, then not conclusion. So H and C stay in the same place. You just put the word not in, or sometimes take the word not out if it's already there. And that's called the inverse. Now the hypothesis is you do negate both of them. You put the word not in or take the word not out. And you also switch. So you switch where the hypothesis and conclusion go. And so you exchange them. And you also put the word not in both of them. Or take it out. If it already had a word not, you take it out. Okay, so we are going to write the converse, inverse, and contrapositive of this statement. If an animal is an adult insect, then it has 6 legs. We're also going to try to tell if they're true or false, each one. And in order to tell if they're true or false, here's what you need to know. Adult insects have 6 legs. No other animals have 6 legs. So only adult insects have 6 legs. Okay. This is our conditional statement. This is how it was written. The blue is the hypothesis here. That's our hypothesis if an animal is an adult insect, and our conclusion is it has 6 legs. Now we're going to write the converse of that. The converse is if an animal, and then we put the, see, here's the conclusion. We exchanged our hypothesis and our conclusion. So the conclusion gets to come over here, and do you see how we had to add an animal there? You can't just say if it has 6 legs, because what's it? So if you're starting with a pronoun, it doesn't make as much sense. Then it is an adult insect. Now, it is an adult insect. That used to be our hypothesis, right? So we exchanged where they were. The inverse, oh, we have to judge if it's true or not. No other animals have 6 legs, so the converse is true. If an animal has 6 legs, then it's an adult insect. So that's a true statement. Okay, now the inverse. For inverse, you keep the hypothesis and the conclusion in the same order. So this was the hypothesis before, and this was the conclusion before, but we put the word not in both of them. If an animal is not an adult insect, then it does not have 6 legs. And then we have to decide if that's true. If an animal is not an adult insect, then it does not have 6 legs. That's also true because the science fact on the page before said that no other animals have 6 legs. So that's true too. Okay, now the contrapositive is when you switch the hypothesis and conclusion around and you put the word not in both of them. So if an animal does not have 6 legs, then it is not an adult insect. And that is also true because of the science facts on the page before. Adult insects must have 6 legs. So if an animal does not have 6 legs, then it's not an adult insect, is a true statement. So these were all true. It's not that often that every statement will be true. There's often pairs of true statements and pairs of false statements. All right, write the converse, inverse, and contrapositive of the conditional statement, and I'm going to rewrite this. If an animal is a cat. Now that's our hypothesis. An animal is a cat. Then it has 4 paws. That's our conclusion. Now we're supposed to write the converse of that. Actually, is that a true statement? Unless there's something wrong with the cat, it's true. So we'll start with our conditional statement, and it's a true statement in general. Don't look for the one kind of cat that you've heard of that only has 3, but the converse is when you switch. The conclusion goes here, and the hypothesis goes here. Now we had to add the word animal so that we didn't start with a pronoun. If an animal has 4 paws, then it's a cat. Is that true? Or could we find a counterexample? Well, my dog has 4 paws, so that would be a counterexample. So that's a false. If you can find one counterexample, it's false. Okay, let's do the inverse. For the inverse, we keep the order the same of the hypothesis and conclusion, but we add the word not. So if an animal is not a cat, then it does not have 4 paws. Well, that doesn't make sense. If an animal is not a cat, let's say it's a dog, and it does not have 4 paws, well, yeah, it can. There's animals that are not cats that do have 4 paws. So this is false. And again, you could do a counterexample, pick an animal. I'll pick dog again, or pick mouse. And then the contrapositive is you do switch the order of the conclusion and the hypothesis, and then you put the word not in there. If an animal does not have 4 paws, then it is not a cat. So we took the converse basically and put the not in both of them. So if an animal does not have 4 paws, then it is not a cat. That's true, because cats do have 4 paws. So the true statements were the conditional and the contrapositives. They were both true. The false statements were the converse and the inverse. And you will find that that often happens, that the conditional will go with the contrapositive. They'll either both be true or both be false, and the converse and inverse will either both be true or both be false. They come together mostly. And that's kind of what this next last thing is, logically equivalent statements. Related conditional statements that have the same truth value are called logically equivalent statements. A conditional and its contrapositive are logically equivalent, and so are the converse and inverse, just like that example we just saw. It's called the law of contrapositive. You don't really have to remember that. Okay, so you are now ready to do your assignment. If you want to, you can check your knowledge and do this quiz. Pause your video, do these 3 problems, and then I'll put the answers up. Okay, a triangle with 1 right angle is a right triangle. The hypothesis would be a triangle has 1 right angle, and the conclusion would be the triangle is a right triangle. I would have written this in if-then form first. If a triangle has 1 right angle, then it is a right triangle. Okay, number 2, if a number is even, then it is divisible by 2, something along those lines. So the hypothesis would be a number is even, the conclusion would be the number is divisible by 2. Unless the word if shows up in the middle of the sentence, usually it's going to go in the order that you wrote it. The hypothesis will be the first part and the conclusion will be the second part, because in English that's usually the way we talk. Determine if the statement if n squared equals 144, then n equals 12 is true. If false, give a counterexample. So if n squared equals 144, then n equals 12. So can we find a counterexample? What if n equals negative 12? That means that the hypothesis is true because negative 12 squared is 144, so the hypothesis is true, but the conclusion is false because it says that the conclusion is n equals 12, and I found one that was n equals negative 12. So that is a false statement. In this one, you were supposed to identify the hypothesis and the conclusion of each conditional. Well, that doesn't make sense, those directions. All we're going to do is what it says. We're going to write the converse, inverse, and contrapositive of the conditional statement. If Maria's birthday is February 29th, then she was born in a leap year, and decide whether each is true. So pause, do the work, and then check your answers. Okay, so the converse would be you flip-flop the hypothesis and conclusion. So you'd get if Maria was born in a leap year, then her birthday is February 29th. You can be born any day in a leap year, not just on February 29th. You could be born in March or June or July or anything. So that is false. The inverse, if Maria's birthday is not February 29th, then she was not born in a leap year. That is also false because, again, you can be born any day in a leap year and still be born in a leap year. And the contrapositive, you flip-flop both the hypothesis and the conclusion and add the word not. If Maria was not born in a leap year, then her birthday is not February 29th. That's true because the only time you have February 29th is during a leap year. Okay, so that is it for our lesson. Thank you very much. Please let me know if you have any questions or concerns as you are working on the assignment for Chapter 2, Section 2. Thank you.